Today we're going to continue talking about slope, and this time we're going to talk about slopes of parallel and perpendicular lines. So first let's have a chat about what it means to be parallel or perpendicular. So here I have two graphs of lines, and in this first one on the left, I want to draw a line that's parallel. You don't have to draw the line, but I want to show you an example. And what we need to know is that parallel lines have the same slope. Parallel lines are two or more lines, we can have multiple parallel lines, two or more lines that will never intersect or cross each other in the coordinate plane. That means no matter how long these lines go, and if you remember, lines have arrows on the end of them because that means they go on and on forever, even though we can't draw that. Parallel lines, if they went on and on and on forever, they would never cross each other. And that's what makes them parallel. And the thing that allows that to happen is them having the same slope. If they're slanted the same way, they're never going to cross because they're always going the same way. And so remember that we could find slope. Our slope is m. We would subtract our y's. I'm going to abbreviate subtract and divide by subtracting our x's. In the coordinate plane, we can do that by counting, starting at the left point, counting down 5 and right 2. Remember, 5 or down is negative, right is positive, so the slope of this line is -5/2. And so if I'm going to graph a line that's parallel to this, I need it to have the same slope. So I can put any point on this coordinate plane, and if I go down 5 and to the right 2, I can create a line that's parallel to it. Those two lines, now I know I didn't draw my line perfectly straight, but we're pretending. If we can imagine them going on and on forever, those two lines will never cross. Those two lines are parallel because they have the same slope. Perpendicular lines will cross. Perpendicular lines make right angles, 90-degree angles. And their slopes are slopes have opposite signs. So one is going to be positive and one is going to be negative. And then they are flipped fractions. The technical word for a flipped fraction is a reciprocal. So if you want to remember reciprocals, that's great. If you want to remember flipped fractions, that's also great. We can, if we know the slope of our line and we want to find a slope of a line that's going to be perpendicular, then we can switch that side or that slope sign, and we can flip the fraction. We can find its reciprocal. And so if I'm looking at this blue line on the right here, I can find its slope. So I'll start with the formula. It's good to always write it so you can just keep reminding yourself, keep reinforcing what that formula is. I always start on the left, so I pick a point on the left, and then I'm going to go up 1, 2, 3, 4, 5. Up is positive, right 3, right is positive. My slope is 5/3. Remember, up, down is the y direction, so that goes on top. X is the left-right direction, that goes on the bottom. So if I want to find the slope of my perpendicular line, I'm going to take this fraction and I'm going to flip it over. And let me use this little symbol. The upside down capital T means perpendicular. I will flip my fraction over. So 3 is going to go on top, 5 is going to go on the bottom. And it's going to have the opposite sign. So since my slope before was positive, my new slope is negative. So that means I could pick any point in the coordinate plane. And if I go down 3 and I go right 5 I'm going to end up with a line, if I connect those 2 points, that's perpendicular to my first line. And I didn't draw it perfectly straight because I don't have a straight edge here, but those 2 lines should make 90-degree angles. They should make right angles. They're only going to intersect this one time, right there, and then they'll never touch again. So parallel lines have the same slope and they never touch. Perpendicular lines have slopes that are flipped fractions, they have opposite signs, and they touch once and they make 90-degree angles. So we can find those slopes if we're given the coordinates as well. So we found slopes using Desmos. We're going to subtract the y's and divide that by subtracting the x's. So reminder, I can put these coordinates into a table. It helps me stay organized. So I'm going to put these coordinates into this table. And just make sure they go in the right spot. You can see that it's easy to make a little mistake. And so I have my coordinates in there, and we're subtracting the y's, and then we're subtracting the x's. So let's subtract the y's first. 10 minus negative 19. I get the first minus because I'm subtracting. I get the second minus because I have a negative 19. And then I'm going to subtract the x's, negative 8 minus negative 10. And so I have my slope, 29 on top, 2 on the bottom. I can check to see if that simplifies. 29 divided by 2. Click the little fraction button. That's as simple as that slope gets. So the slope of this line is 29 over 2. Parallel lines have the same slope. Let me give you some more notation. These 2 little lines mean parallel. So my parallel slope is going to be the same. My perpendicular slope, upside down capital T, I'm going to flip this fraction over and change its sign. My original slope was positive. That means my new slope for perpendicular is negative. And now we have those 2 slopes. I want you to pause here. We've talked about parallel and perpendicular line slopes. We talked in the last lesson about finding slope. So I want you to pause here, use Desmos, find the slope of this line, and then find the slope of the parallel line and the perpendicular line, and then press play and check your answers against mine. So I hope you paused and gave this a try and used Desmos if you wanted to, if that's helpful for you. You should find that the slope of our line is 14 over 31. So if we graph the line through those 2 points, it would have that slope. Any line that we could graph that's parallel to it should have the exact same slope. So we don't really have to do anything there. We just have to note that it's the same. For the perpendicular slope, the line that's going to cross it once and make a right angle, we're going to flip that fraction over, put 31 on top, 14 on the bottom, and then change it to being a negative slope since the original slope was positive. If you didn't get these right and you need some help, please do ask for help. There's 2 of us here, and we'd be glad to help fix that mistake with you. And then the last way we found slope was by looking at the equation. Remember that the number in front of x represents our slope m. And so if I'm looking at this equation, that slope is negative 2 over 3. And so that means any line that I draw that's parallel to this line is going to have that exact same slope. If they're sloped the same, then they'll never touch. That makes them parallel. Any slope or any line that's perpendicular, any line that's going to intersect that line once and make a right angle is going to have a flipped fraction. So we'll flip this over and make it 3 over 2. And then we're going to change its sign. So the sign for this entire fraction of our original slope was negative. And so we will have a positive slope for our perpendicular slope. So we don't have to put any signs there. We just assume it's positive. Same thing for this other one. The number in front of x here is 6. That means our slope is 6. It might be helpful to write this as a fraction. You can write any number as a fraction, if it's not already, by dividing it by 1. So that means the slope of our parallel line is 6 over 1. And to get the slope of our perpendicular line, we're going to flip that over. That's why it's helpful to have a fraction. Flip that over, put 1 on top, 6 on the bottom, and then our original line was positive slope. Our perpendicular line is going to have a negative slope. As always, if you have questions, please make sure that you're asking. Please make sure you get anything that's confusing answered for you. There's 2 of us here. Stick around to the end. Make sure you answer the questions at the end. And if you're working through those and you need help, always ask for help. We're glad to help you. Take your time and good luck.